Hi, everyone. So we're going to start the lecture here is going to be pretty short on nomenclature. There's three different types of nomenclature that we'll cover: ionic, covalent, and the nomenclature for acids. So first of all, for the ionic nomenclature is between a metal and a non-metal. So the thing to remember is that metals always form positive ions called cations, and non-metals always form negative ions, and they're called anions. So what happens is that the ions pair to form neutral compounds. So as my first example, I'll use barium chloride. Barium's a metal. The chlorine, which becomes chloride, is the non-metal. The metal always comes first. So barium, we say, has a +2 charge, and the non-metal chlorine has a -1 charge. Well, how do I know that? I know that all alkaline earth metals of group 2 have a +2 charge. And so that's true for everything in that group 2, in that whole column. If I step to the left one on the periodic table, all the alkali metals, the group 1 metals, have a +1 charge. Then if I go way over to the right, to the second to the last column, group 17, the halogens, those are non-metals, those all have a -1 charge. And then I go one left of that to group 16. They are non-metals and they all have a -2 charge. Now, there are some other ones that you just have to know, or you look them up, and it's that aluminum is a +3, zinc is a +2, and silver is a +1. So that being said, you need to know the charge for both your metal and your non-metal before you can determine what the compound formula is. So what we'll do here, once we identify the charge, the +2 here on the barium, the -1 on the chloride, I always say that you do a crisscross. You take the charge number on the non-metal and it becomes the subscript of the metal. And then the same thing here, you take the charge of the metal and it becomes the subscript of the non-metal. You don't bring the sign of the charge down, you just bring the absolute value of that number. So this formula becomes BaCl2. So let's look at another example. Aluminum oxide. So aluminum is one of those ones that you just would have to know or you'd look up, is a +3. Oxygen, being in the group 16, as we stated above here, is always a -2. If I do the crisscross, the aluminum gets a 2 subscript, the oxygen gets a 3 subscript. And then another type of example here is when the charges are equal and opposite. So calcium coming from group 2 is a +2. Sulfur coming from group 16 is a -2. If I do the crisscross here, it becomes a 2-to-2 ratio for the subscripts, but we don't want that. We always want to reduce to the simplest whole numbered ratio, and it would become CaS, and it would not be Ca2S2. And so what we're seeing here is that we have this IDE ending in each of these examples that I just did. You have the IDE ending. And so what I've highlighted down here is the fact that you always are going to have an IDE ending on a monatomic anion. Monatomic is just any element that is by itself, which is different from a polyatomic ion, which we'll talk about in our next segment. I'm going to stop there.